So you can be going through the previous lesson as you wait to start on this lesson.
Okay, fine, thank you. Let me take this opportunity again to thank everyone. I thank God, of course, for enabling us to make it again today. I welcome each and everybody in this meeting. Benjamin, I see you have never missed my lesson. Benjamin.
Yes, sir.
You have never missed my lesson. Thank you for being always there, following the lesson one by one. I pray to God that at least you benefit something there. And then Tracy, you have also never missed the lesson. Tracy, you have never missed any of my lessons.
Teacher.
I can hear you.
Yeah, we are going to mute all of them, then you'll be asking them to unmute.
Yeah, it's okay. I can. So, Tracy. Okay, Tracy, I see Shivan. Shivan, you can unmute. Shivan?
Yes, teacher.
You can greet us, then after greeting us, you pray for us, we start the lesson.
Okay.
Yeah.
Good afternoon, everyone.
Good afternoon, how are you?
Fine, thank you.
Good, you can take us through the prayer and then we start our lesson.
Let's humble ourselves for the prayer. Heavenly Father, I'd like to thank you so much for today. Thank you so much for gathering us here so that you can learn our physics lesson. We thank you so much for the teacher that's going to take us through, and we pray that whatever we are going to learn will be used for the best and we shan't forget it. In your mighty name I pray and believe. Amen.
Thank you so much for the prayer. We will start right away with a recap of what we saw in our last lesson. I believe good number of you are available. I see Tracy is around. I see Kevin. I see Benjamin, Rahama. You are all around. Can Benjamin kindly remind us what we saw in the last lesson?
Yeah, in the last lesson, we studied about the setting up of the Kelvin scale.
We saw establishing Kelvin scale. Good. We saw setting up a Kelvin scale. We said that if you are to set up a Kelvin scale, what you need to choose the thermometric property. When you choose the thermometric property, what you do, you label it to be X. Up the Kelvin scale, after choosing the thermometric property, you label it to be X. Then after that, you measure that thermometric property at triple point of water. Then after measuring it at triple point of water, you measure it at unknown temperature. So at triple point of water, we said you label it to be xt hour. Then at unknown temperature, you label it to be x theta. Then from there, you determine the value of theta from the expression. Theta equals to x theta over xt hour times 273.16 Kelvin. That's how we will set up our Kelvin scale. Rahama, is that what we said? I see Lois is having the hands up. Yes, Lois?
Excuse me, sir, I'm not seeing your screen.
I had not yet started sharing my screen. We were just having a recap of what we studied. Is that okay?
Yes.
Okay. So can somebody confirm that we saw that last time? Yes, Rahama?
Yes.
We saw that one, okay?
Yes.
I set some assignment on our Google Classroom. I marked very few. I marked very few of you. That means that very few submitted. Can I see the ones, those who submitted? Just raise up your hand. Those who submitted the assignment. Yes, Benjamin submitted. Yes, Rahama submitted. Okay. Fine. So, today, we are going to see yet another stuff. And let me share my screen with you. Hope you are able to see my screen. Are you able to see my screen? Are you able to see my screen? Lois, can you see my screen?
Yes.
Good. That means the rest can also see. I see Tendo. Tendo, can you see my screen? Tendo? Okay. Brian, can you see my screen, Brian? Mayumba? First unmute. Okay. Bridget, can you see my screen? Okay. Good. So,
FN mode.
going to
FN mode. Bluetooth mode.
This one is for the newcomers. My name is Teacher Daniel Alira, and we are in Senior 5 class. For those who have just joined us today, you're most welcome. Today, we are going to discuss liquid in a glass thermometer. We saw setting up a Kelvin scale. We saw setting up Celsius scale. So today, we are going to see liquid in a glass thermometer. In other words, we are discussing different types of thermometers now. And we are starting with the liquid in a glass thermometer. Types of thermometers is what we are discussing. We start by saying a liquid in a glass thermometer. We say that a liquid in a glass thermometer, it uses a thermometric property, which is the length of the column of the liquid to measure the degree of hotness or coldness of the body. Now, before we saw how to set up Kelvin and the Celsius scale, we saw very many thermometric properties. We said thermometric properties are those physical properties which change linearly and continuously with change in temperature, of which who can remind us some of the examples of thermometric properties? Benjamin?
We had length of mercury thread in the mercury glass thermometer.
Very good. Length of mercury thread in mercury glass thermometer. Justin?
The electrical resistance.
Very good. Electrical resistance in a in a platinum resistance thermometer. That was good. Can give us another one? Emma? Emma? Oh, Alfred Okema, you are here. Thank you for coming for sure. Alfred, can you give us some of the thermometric properties which we discussed? Yeah, can you give us some of the thermometric properties which we discussed? Alfred? Oh, your network is not allowing. It's okay, your network is not allowing. Good. So we're saying, what you're saying, we're saying that liquid in a glass thermometer uses one thermometric property, and that thermometric property is the length of liquid column. Length of a liquid column can be the length of mercury in a mercury glass, can be length of alcohol in alcohol glass, can be length of water in that. But the thermometric property here is the length of the liquid what? Liquid column. So the thermometric property used in liquid glass thermometer is the length of the liquid column in that glass thermometer. So you say that it uses a thermometric property which is the length of the column of liquid to measure the degree of hotness or coldness of the body. So this liquid usually may be either mercury or alcohol or even what? Or even water. But we're going to see the choice on which, or the three, depend on. How do we, when do we choose this? When do we choose alcohol or mercury or water? The choice of choosing any thermometric property depends on some of the properties. Good. So the liquid which may be used in liquid glass thermometer may be alcohol, may be mercury or water. Good. Then, how does it work, the liquid glass thermometer? Now, for you to use a liquid glass thermometer, you simply need that thermometer. Of course, the thermometer will be having the liquid already inside. We are not sure whether the liquid is water, whether the liquid is mercury, or the liquid is what? Is alcohol. Whatever the liquid may be, but as long as I have the thermometer, what I will do, I will first put the bulb of the thermometer in ice. Should be pure melting ice. You know, one of the factors which affect melting point is also the purities. When there is presence of impurity, then it causes what we call to be melting point, freezing point depression, and it also causes boiling point elevation. So we're saying, if I have the thermometer, that thermometer, I want to use it to measure the temperature, let's say water, which I don't know its temperature. And of course, it does not give the direct reading. What I do, I get that thermometer. The thermometer is like this. Let me know if you can see what I'm drawing. It has a bulb. Okay, this part is called the bulb. Then it has the mercury thread column here with some marks here. This is what you call to be the thermometer. It's not the temperature gun. So this bulb, what I do, I lower it into a container of ice. Then after lowering into a container of ice, I allow it to stay there until the length of the mercury thread is constant. Then I take the reading of the length of the mercury thread. I call it to be L naught. L naught means the length of the mercury thread when the bulb is in ice. And sometimes we call this one to be ice point. We're determining the ice point. If you don't want to call it to be ice point, you can call it to be 0 point or melting point. So I get this ball, I put it at ice, in ice, I determine the length. Then after, I put this bulb in steam. Steam is boiling, pure boiling water. Then after putting it in steam, I will allow the bulb to be there until when the length of the mercury thread is constant again. Then I measure that length as L100. So what I've done here, the first one and the second one, in physics, we call it to be calibration. It is called to be calibration. Calibration in physics, as far as a thermometer is concerned, it is determining the upper fixed point and the lower fixed point. So the upper fixed point is the steam point, the lower fixed point is the ice point. So after doing that, after determining the lower fixed point, the upper fixed point, I get now this thermometer, then I put it in that place or in that water whose temperature theta is required. Then from there, we expect the length of the mercury thread also to increase. We allow it to change until it becomes constant again. When it becomes constant again, we read that length as L theta. Then the temperature theta is calculated from L theta, from theta equals to L theta minus L naught over L100 minus L naught times 100 degrees. So you will eventually be in position to find the value of theta. I want you to note that this is the simplest thermometer to use. You don't need to go to school to learn how to use this. You just need to get somebody like me. I tell you what to do. I tell you, please, Alfred, can you calibrate? I just tell you, oh, Justin, can you calibrate? I tell you, Jerry, calibrate. I see Julius, King Julius, King Julius, King Julius, King Julius. Can you unmute yourself? Okay, you cannot. Esther, gift Esther. Can you unmute yourself? Gift Esther.
Yes, please.
Do you hear us?
Yes, I can hear you.
Have you understood what I just explained?
No, please.
Sorry?
No, please. I was having some challenges.
Oh, you are not yet joined, eh?
Yes.
Okay, it's fine. Lovins, I see your hands up. Lovins. Joy. Joy. Unmute. Joy, can you unmute? Okay. Joy, Joy, your hand was up.
Ask you can repeat the explanation of how it works.
Okay. Kale, we said if we are to use the mercury in a glass thermometer, what you do, you get the thermometer. But before you get the thermometer, you should be in position to know that mercury in glass thermometer uses the length of the mercury as a thermometric property. So while we have been calibrating, we put the bulb in ice, then from there we allow the bulb to be there until we get the constant length, and we record that one to be L naught. Then after get the thermometer again, I get the thermometer again, and I put it in an enclosure of steam. Do you see the steam?
Yes.
The steam is always at 100 degrees Celsius. So we put it in steam. After putting it in steam, we record the length as L 100. Is that okay? Then from there, we put the bulb in contact with the unknown temperature, theta. This is the temperature which you want to determine. Then from there, you label the length to be L what? L theta. Then from there, theta is calculated from this expression. Is that okay?
Yes, sir.
Okay, please. Can I move to the next slide? If you have any question, you raise your hand up. I will be in position to see. Good. Now, let's go to advantages of a liquid in a glass thermometer. The instruction is very simple. Without seeing on my screen, what do you think are the advantages of this type of thermometer, liquid in a glass? Raise up your hand. What are the advantages of liquid in a glass thermometer? What are the advantages? Raise up the hand. Do you have any advantage? Yes, Benjamin.
Yeah, it's just a trial.
Yeah, it's okay. We are here to learn. There's no problem.
It is cheap to make.
It is cheap, very cheap. It is too cheap. When you go to buy a thermometer with 2,000, liquid in a glass thermometer with 2,000, I have a feeling that they can give you like 30 of them. I'm not very sure, please, I don't deal with that business. But it is too cheap. Unlike temperature gun, which was costing around 150, 60,000, that one. During time of COVID, you know how much people bought temperature gun. People didn't know they would have used what? They would have used the other thermometer. Yes, Justin? Justin?
It is.
Sorry?
It is portable.
It is portable. Some, I don't know, but sciences are not thieves, but I remember in O-level, we had people who could even steal the thermometers, putting it in the pocket. But do we have sciences who are thieves? Rahama, can you answer that question? Do you have sciences who are thieves?
No.
Okay, one day you'll be surprised. So it is portable. You can even put in your pocket, and then you go after coming from the laboratory. Let me hear from Rahama. Which other?
Yes.
Which other do you have?
It can be used. It can be used to measure temperature at a point.
Can be used to measure temperature at a point. Very good. Can be used to measure temperature at a point. But thermocouple, you are yet to see that. Thermocouple also does so. Thermocouple can also measure temperature at a point. So it can be used to measure temperature at a point. Joy Loving. Joy Loving?
It is easy. It is easily seen. I'm just trying.
Yeah, it's okay.
Okay, it is easily seen. That's my answer.
It is easily seen. I think you can paraphrase that by saying that it can give direct reading. Okay? Is that it? That? Yeah, it can give direct reading. You don't need very many things. You don't need a calculator to do it, but gives you direct readings. So those are some of the advantages of liquid in a glass thermometer. Let's see what is here. The first one, it is use. So it does not require a skilled person. Is that okay? Then 2, it is very cheap. You don't need a lot of money. You don't need to be rich for you to buy it. Then 3, it is portable. You can just steal and go away with it. Though we are Christians, we are not allowed to steal. Then lastly, it can give a direct what? A direct reading. So those are some of the properties, advantages of liquid in a glass thermometer. When I was still growing up, and even up to now, when I'm faced with a challenge, it has an advantage. If it's a challenge, it has an advantage and a disadvantage. If it's an opportunity, it has also the other part, the good part being an opportunity, and also the other bad part. It also is there. So much as we are talking about advantages of mercury in a glass thermometer or liquid glass thermometer, we have to be aware that much as it is cheap, okay, it is also having some other disadvantages. It has also some other disadvantages. So, can we figure out some of the disadvantages of liquid in a glass thermometer? Disadvantages. Take on spark. Can you unmute? Can you rename yourself? Yeah, I got that.
A lot of care is needed as it is fragile.
A lot of care is needed.
Yes, as it is fragile.
Yeah, it can easily break. If you handle it carelessly, you may end up losing it.
Yeah.
Me.
Take Mr. Rukundo Omara. Rukundo Omara. Yes, I have a friend called Rukundo. Yeah, Rukundo.
It sticks on the holes of the thermometer, making it uneasy to be read.
It can stick on the wall of the thermometer, and for that case, it can make it hard to use it. Okay, good. Let me hear from Rahama. Please, the rest, if you want me to pick you, just raise up your hand. Okay, I'll pick you right away. The class is for all of us, not for some few individuals. Okay? Yes, Rahama.
It cannot be used to measure temperature over a wide range.
Very good. Now, when you looked at this mercury for sure, its melting point, its boiling point is just 138 degrees Celsius, and it freezes at negative 32 degrees Celsius. So anything beyond 138, you can never use it. You can never use mercury to measure it, mercury glass thermometer. Anything below negative 32, you can never use it. So it cannot be used to measure temperature, which are very high. So we say it cannot be used to measure wide range of temperature. Thank you so much, Rahama, for that wonderful answer. I still see some hands up. There's some people who have not talked. Yes, you are there. Ellen, you have not talked. I need audio. Trust you cannot fail to talk in my class. Can you talk? Trust can you talk, please? Trust can you tell us the disadvantages of The glass thermometer. You want to disappoint me? Okay. Next year's, can you say a word? Yes. Unmute and say something. Okay. Let me go to, yes. Rename yourself. You can say something. I see your hands up. Please say something. Okay, fine. Let me lower your hands down. Then let's see the disadvantages. The disadvantages. Much as you're saying that it is cheap, but it cannot measure temperature over a wide range. So you're saying that it has small range of temperature. Higher temperatures, it cannot measure it. Very low temperatures, it can also not measure it. Then two, it is very, very inaccurate. It is very inaccurate. It is not very accurate. Is that okay? Then lastly, it is very fragile. Just like how Rahama gave it to us, very fragile. And so you need to take care when you're handling it. Is that okay? Okay. Glass capillary is, in most cases, not uniform. Good. That one is from TechnoSpark. I don't know your name. TechnoSpark says it always changes in the temperature when the barrel shrinks. Very good. Hence, not very accurate. This is. Wait. So you're saying that what's the problem, Benjamin? We are back, don't worry. So it is very inaccurate. So these are the differences. Now, let's see other things. Sources of errors. What makes it very, very inaccurate? One, there is non-uniformity of the bore of the capillary tube. The capillary tube is not uniform. That is one. Two, the glass contracts and expands. So it can either contract or it can expand. That's the glass. And so it takes long hours to recover its correct size and shape. And therefore, it spoils the calibration. Then there is that last part of parallax error. There is error of parallax. Error of parallax, it's like when you're reading, but you don't read the exact value. You either see from above or from below, not from the exact point. So that is parallax what? Parallax method. So these are the sources of errors in measuring glass thermometer. Is there somebody with another addition? Yes, Raham? Yes. Yes, Braham, I see your hands up.
I would like to add on.
Yeah, you had it for us.
Shrinking of the zero mark due to usage from the date of the manufacture.
Very good. That is good. Shrinking, that is contracting and what? And expanding. Good. Then who can add it for us again? Another one. Who can add for us the sources of errors in measuring glass thermometer? Raham, you want to add another one?
Yes.
Uh-huh.
Temperature of mercury in the bulb in the capillary tube may not be the same.
Temperature of the bulb. Temperature of the bulb. Yeah, you see.
The capillary tube may not be the same.
Yeah, when the walls of the bulb is too thick, when the walls of the bulb is too thick, then the temperature of the mercury in the bulb may not be the same as the temperature of the bulb. And so it may give wrong wrong reading. Gift S is saying, do you send notes about what you have taught after? Yes, I do send gift. I send the notes on Google Classroom, and sometimes we share on our on our WhatsApp. So we are saying that these are the sources of errors. Can you add for us another one? You can add for us another source of error. Yes, Bright Raham. Raham. Your network is not very clear. Raham. Oh, sorry, it's fine. Let's go to the next thing. And it is reasons why water is not used. I mean, why mercury is used as thermometric properties. I believe you have some good numbers of reasons. Can you give us the first one? Why do you think we use mercury in a glass thermometer? You can raise up your hand.
The answers are displaced.
Let me remove my screen. Raise up your hands. John, let me know if you have not read from mine. Yes, John. Yes, John.
Mercury does not stick on the walls of the thermometer.
Very good. It does not wet or does not stick on the walls of the thermometer. And we have the reason for that. In mercury, the cohesive force of attraction is greater than the adhesive forces of attraction. And so it does not stick there. Yes, Joy Lovin?
It's opaque.
Very good. It is opaque, and so it can easily be read. It can easily be seen. Yes, Esther?
Expands easily.
Yes, Esther?
It expands easily.
It expands easily and uniformly. Very good. It expands easily and uniformly. Thank you so much. Who wants to add another one? Tendo? Tendo?
It's a good conductor of heat. Does respond quickly to temperature changes.
Very good. It's a good conductor of heat. This class is a nice class. I like it. Good. So let's go ahead and see what is there. One, does not wet the glass. The reason we have given already, it does not wet the glass because the cohesive force of attraction is greater than the adhesive force of attraction. Then number two, it is opaque. Number three, it expands uniformly and continuously, of course, with changing temperature. Then number four is a good conductor of heat. So those are the reasons why mercury is used as a thermometric property. Oh, there's a reason why we don't use water. Yes, the reason why we don't use water is because water does not possess all the other reasons why we use mercury. Do you hear that?
Yes.
Yes.
So, if you know the reason why we don't use, why we use mercury, the reverse will be the reason why we don't use water. Is that fine?
Yes.
Yeah. So, can you sample for me 1 or 2? Benjamin?
Water sticks on the walls of the thermometer.
Very good. It sticks on the wall of the thermometer, that it weights the wall of the thermometer. Yes, John? Yes, John? Yes, Esther? Esther?
It's a poor conduct of heat.
The poor conduct of heat, that is okay.
It's a poor conduct of heat.
Yeah, that is very fine. Then, Rahama?
It is transparent.
It's transparent. Very good. Very good. So those are the properties why they are not used. The reason why water is not used. So you're saying it weights the glass. It is not opaque. It's a bad conductor of heat. It has non-uniform expansion. That is non-uniform expansivity. Good. So those are some of the reasons why water is not used. Good. Now, that is briefly about liquid in a glass thermometer. Is there any question on liquid in a glass thermometer? Is there any? Is there any question? You can raise up your hand and I'll pick you. Let me see. Yes, Esther, I see your hand is up. Yes, Esther. Yes, Esther.
No.
You don't have any question? Justin? Justin, do you have any question?
Yes, teacher.
Yes, please go on and ask.
My question is like now, if the question comes with the reference to liquid in a glass thermometer,
yes,
describe. Describe like how we can obtain a Kelvin scale using liquid in glass thermometer, but here we have used the Celsius scale.
Okay. Now they say describe how you can use liquid in a glass thermometer to establish Kelvin scale. They say the thermometric property, remember, we already know liquid in a glass thermometer, the thermometric property is already the length of the mercury column in the mercury glass thermometer.
Column.
So we say the thermometer is put in an enclosure which is at a triple point of water. Is that okay? The thermometer is put in an enclosure.
Yes, teacher.
It is put at triple point of water, and the length of the liquid column LXT hour is measured and recorded. Is that okay?
Yes, teacher.
And from there, you say the thermometer is then placed in an enclosure or in the body whose temperature is required. Is that okay?
Yes.
And from there, the length of the mercury column, L theta, is measured and recorded. Then the temperature theta is then calculated from theta equals to L theta over Lx hour, LT hour times 273.16 Kelvin. That okay?
Yes. Okay. Thank you, teacher.
Okay, please. I see Benjamin is having hands up.
Yeah. Referring to the procedures, how it works. At the last, I'm seeing that we have there a formula. So does this mean that they can easily set a calculation number from this thermometer?
Yeah, it can easily be set. Because they can tell you that the length of a mercury glass thermometer ice point is 100, at steam point is 105, and at unknown temperature theta is 5 degrees. Okay? Find the temperature. I think we have done a calculation of that time. No, sir? Did we? Benjamin? Okay, and thank you. So, Benjamin says, yeah, we did. Yeah, that's okay. So, resistance thermometer. Resistance thermometer, and in this case, we are going to pick platinum resistance thermometer. One of the thermometric property which we saw variation of resistance in platinum resistance thermometer. And why platinum? Platinum is a metal itself. We would have even other metals to be used. We have metal like zinc. We would even say zinc resistant thermometer or aluminum resistant thermometer. But we chose platinum. Why did we choose platinum? There are two properties or two qualities of a metal to be used as resistance thermometer. Do we hear that? There are two properties. There are two properties that a metal must be having for it to be used as a resistance thermometer. And the first property is that metal should have very high temperature coefficient of resistance. That metal should have very high temperature coefficient of resistance, so that for any small change in temperature, there is always a measurable or a noticeable change in resistance. So one of the properties is that the metal to be used as a resistance thermometer must have very high temperature coefficient of resistance. Good. So I have a question. What is temperature coefficient of resistance? I've already studied electricity. It is in physics 2 and electricity, temperature coefficient of resistance. Who can define for us temperature coefficient of resistance? Raise up your hand. Temperature coefficient of resistance? Yes. Loving? Yes, Loving. Yes, Loving. Loving.
Sir, can you hear me?
Yeah, I can hear you.
So I'm taking you back to the liquid.
It's okay.
So I wanted to ask about the thermometric property of the liquid in a glass. Is that also included among the properties we first introduced?
Yeah, it was included. We said The first thermometer property we listed was length of the mercury, length of the liquid in a liquid glass thermometer. If you remember very well.
Yes.
So it was included there.
So it is actually part of that point.
Yeah.
Okay.
Ale. Can you also go ahead and define for us temperature coefficient of resistance? Have you studied electricity already?
Actually, no.
Okay, please. There's no problem. Spark, go. Are you defining for temperature coefficient of resistance?
Yes.
Please go on.
Temperature coefficient of resistance is the fractional change in resistance per degree temperature rise.
Very good. Very good. You miss only one word, okay? It's the fractional increase in resistance or fractional change in resistance at 0 degrees Celsius per unit temperature rise. The fractional change in resistance at 0 degrees Celsius per unit temperature rise is what we call to be temperature coefficient of resistance. The rest who have not studied, don't worry, you see it in electricity. So for a method to be used as a thermometric, as resistance thermometer, it is supposed to be having high temperature coefficient of resistance. Do you hear that, members? Do you hear that?
Yes.
Okay. Then the property number 2, the variation of resistance with the temperature should be linear. Variation of resistance with the temperature should be linear. Is that okay?
Yes.
Very good. Now, I have a simple question. And the question goes, why do we use platinum as a resistance thermometer? Who can answer it? Who can answer it? Yes, Esther.
It has a wide range of temperature.
Yeah,
Only that.
Only that, okay? Fine, thank you.
Yeah.
Let me hear from Justin.
Platinum wire has a very high electrical resistance.
Temperature coefficient of resistance. Very good. Not only that, but also yes, can I hear from Raham?
Variation of resistance.
Yes, Raham, right?
Yes.
Can I hear from you? Why do we use platinum resistance in the thermometer?
It is suitable for measuring small steady temperatures.
Okay, thank you. Yes, Benjamin?
It is because its variation of resistance with temperature is linear.
Very good. And also?
It has a high temperature coefficient of resistance.
Very good. Thank you so much. Thank you. Thank you. Okay. So my network is not okay. That one is Mirable Precious says our network is not fine. Good. Then the next is that one. Why platinum is used in resistance thermometer? Platinum is used is because it satisfies all the other above two, which we have discussed, okay?
Yes.
Yeah, I will not repeat it down here. We satisfy all the other two. Then let's see how it works. Then we end it. This is the structure, platinum resistance thermometer. Is that okay? The whole of this part. Do you see the whole of this part?
Yes.
The whole of this part, we have it in the electricity. It is called Wheatstone bridge circuit. Is that okay?
No.
Wheat, I'm writing it here. Wheat, stone. Wheatstone, bridge. Bridge, the normal bridge, you know, okay? The whole circuit is called Wheatstone bridge circuit. Is that okay?
Yes.
It has a principle. When you connect the switch, then after, then you adjust this one. Do you see this S? This is a rheostat. This work is to adjust the current flowing. So when you adjust the current flowing, and galvanometer shows no deflection, okay? When the galvanometer shows no deflection, that means that this resistance is equals to the resistance, this part, okay? And also, this resistance is equals to this what? This resistance. Is that fine?
Yes.
Yeah.
Yes.
Yes. Good afternoon. So from we see how let's see how it works. The slide says that platinum wire is put in ice. You put the other wire in ice and you vary the resistor S until when the galvanometer shows no deflection. Showing zero reading means that it is showing no deflection. So from there, I told you already, this R1 is supposed to be equal to R2 from the other diagram. R1, this one is supposed to be equal to this one, and this one is supposed to be equal to this one. Is that okay? Hello, there's something which has happened here, okay? Hello, do you hear me?
Yes.
Something has just happened here. We are going to end the lesson here. We shall continue from here next time. Is that okay?
All right. Thank you.
Thank you so much for attending.
Excuse me?